Okay. Hello everyone. My name is Dr. Shabin Taj. I am here to present session 3 digital transmission in the subject data communication. The table of contents or the topics which will be discussed in this session are different line coding schemes, unipolar and polar. In unipolar, non-return zero, polar, non-return zero, return zero, and biphase. These are the different line coding schemes will be discussed. So we can say here line coding, the different things are there, but in the syllabus it is up to Manchester and encoding is there, Manchester and differential Manchester. So we will be discussing only up to that as per your syllabus. So what is line coding? Let me have quick recap. Line coding is nothing but converting the digital data into digital signal. Digital data being 0, 1 strings of zeros and ones. When you have to transmit, that should be converted to digital signals. Okay. So in order to send to the receiver. What is unipolar? All signal levels so R1 are on one side of the time axis. Time axis you can see either above or below. What you can see horizontal time axis 0 to this. So it will be at the one either up or down. Then it is called unipolar thing. Length coding. NRZ non-return to zero scheme is an example of this code. That means it is unipolar NRZ. The signal level does not return to zero during the symbol transmission. During the transmission, it will not change to zero. It will not return. Hence, it is called NRZ. This scheme is prone to baseline wandering and DC components and it has no synchronization or any error detection. It is simple but costly in power consumption. So whenever you are choosing the line coding scheme, you should keep in mind that whatever the characteristics discussed, it should support that. Okay, what is required? Baseline wandering is not required. DC component is not required. It should have a synchronization, and all this is lack of this. It is not desirable. Unipolar. So unipolar NRZ, I told you, it is it's at any one side. Okay, all signal levels are one side of the time axis. This is time axis 0 to this time axis horizontal line and vertical line represents the voltage in amplitude and it is in unipolar map and the signal data signal it is not returning to 0 at the mid of the transmission. Hence it is not returned to 0 and the normalized power is this given is this. Okay, so which is for the bit level 1 and bit level 0. Okay. Now let us see polar non-return 0. The voltages are here. The voltages unlike in your unipolar, in the polar voltages are the both side of the time axis, above and the below. Polar NRZ scheme can be implemented with the two voltages. Example plus V for 1 and minus V for 0. Okay, there are two versions in this polar NRZ. NRZ-L and NRZ-I. NRZ-L stands for level, NRZ level, NRZ-I represents the NRZ inversion. What are these two versions of polar NRZ? Positive voltage for one symbol and negative voltage for another symbol. That is, for positive one voltage it is used and the negative another. Hence it is called NZR level. NRZ actually it is okay. Inversion. So NRZ inversion, the change or lack of change in the polarity determines the value of the symbol. Example, if one symbol inverts the polarity to 0, one symbol inverts the polarity, 0 does not. So this is what it changes. Okay, let us see. Polar NRZ-L. Here it is at the, as I told you, polar line coding schemes at the both the above and below the time axis. This is time axis and above is there, below is there. Above the positive voltage is representing what? It's shown here plus V for 1 and minus V for 0. Plus V for 1 minus V for 0. Okay. And here you can see NRZ level, this is negative, positive 0 and negative. I think it's given in wrong over here. Okay, plus V is for 0 and plus 1 is for negative voltage for the 1. So you can see 0 is there, this, and there is no return. In between there is no return to 0, and at the time above the both the time axis different levels are used for 0 and 1, hence it is NRZL. But in case of NRZI, so positive voltage at the 0 and it has a negative voltage at the 1, but when again 0 it comes, there is no change. So it will have assumption that if 0 is for the data element 0, no change. For data element 1, there is a change. So inversion, no inversion, next bit is 0. Inversion, next bit is 1. So since 0 is there, no change. Whatever is the previous there, it will continue. 0 is there, it will continue. 1 is there, it will change from 0 to 1. 1 is there, it will change from 1 to 0. 1 is there, 0 to 1. And 0 is there, no change. This is for NRZI. And the bandwidth here represents here R is R1, the average baud rate is N by 2, where N is the data rate and your N by 2. Okay, we have two frequencies, two intervals of frequencies are there. In NRZL, the level of the voltage determines the value of the bit. Okay, so NRZI, the inversion or the lack of inversion determines the value of the bit. NRZL and I both have an average signal rate of N by 2 baud. BD represents a baud. NRZL and NRZI both have a DC component problem and baseline wandering. It is worse for NRZL. NRZL is worse than the NRZI. Both have no self-synchronization and no error detection. Both are relatively simple to implement. So let us see one example. A system is using NRZI to transfer 1 megabits per second data. What are the average signal rate and minimum bandwidth? The average signal rate is equal to, given by the formula C into N into R. C into R. So which is nothing but C is the case factor, N is the data rate. Now here C is 1 by 2. Case factor is assumed that 0 to 1. So it is 1 by 2, N being 1 and R is 1. So here it is 500 K baud. So what? The minimum bandwidth for this average baud rate. Baud rate and signal rate are same. So B minimum bandwidth is, what is that? It is by 2 is given, no? So here it is given as 1 megabits per second. So it is 500 kilohertz. C is equal to half for average case. As worst case is 1 and the best case is 0. Okay, this is what. Now what is polar return 0 line coding scheme? The return to 0 scheme uses 3 voltages, plus, 0 and minus. 0 that is on the time axis, plus we'll see above the voltage time axis, below the voltage, below the time axis. Each symbol has a transition in the middle of the data transmission. It has a transition, but every time it returns to 0, hence it is called polar return 0, either from high to 0 or from low to 0. This scheme has more signal transitions, 2 per symbol, okay, and therefore requires a wider bandwidth. Bandwidth is more. No DC component or baseline wandering. In this there is no DC or baseline wandering. What about the self-synchronization? Transition indicates symbol value. More complex as it uses 3 voltage levels. The complexity increases, hence the baud rate is also more. It has no error detection capability. Every scheme has a pros and cons. In this also there is a pros and cons. With pros is no DC component and baseline wondering, and transition indicates symbol value. But cons, the disadvantage is it has the complexity is more, and it has more signal rate and no error detection capability. Now polar RZ scheme, you can see at the mid of the signal there is a transition from low to high. When it is going for the voltage, negative voltage is showing, it is in between, in mid of the signal it is going from the zero to every zero. See, every signal it is going in between zero. So here 1 it is transmitting, it goes to 0. So it is 0, goes every mid of the signal, hence it is written 0. The bandwidth, the R is 1 by 2, that is one signal element is 1 by 2, one data element is carried by the two signal elements, 1 by 2. And bandwidth is more. Why? Because here there is a three values are there. 0, negative voltage, 0 and 1. What is polar biphase? Manchester. In this you have Manchester and differential Manchester. Manchester coding consists of combining the NRZL and RZ schemes. So what is that? NRZ level. Every symbol has a level transition in the middle from high to low or low to high. It uses only two voltage levels. Okay. So differential Manchester, its coding consists of combining NRZI and RZ. So NRZL Manchester, NRZI with combination of RZ is differential Manchester. Here every symbol has a level transition in the middle, but the level at the beginning of the symbol is determined by the symbol value. One symbol causes level change, the other does not. We'll see with the pictorial example. So now here bipolar phase Manchester, 0 is nothing but high to low, 1 is nothing but low to high. What is that? Now we can see Manchester, 0 to high, means high to low. This is represents the value 0, 1 represents this. Similarly, this. So here it is combination of what? NRZL and RZ. RZ scheme means what? It is returning to the 0. Yes, it is returned to 0 at the mid of the signal. Fine. This is satisfied. NRZL because it uses two different level voltages. Hence, this is Manchester. And okay, differential Manchester is what? No inversion. Next bit is 1. Inversion. Next bit is 0. Okay. So now here this differential Manchester, here the voltage 0 to 1 is represented because it is inverse of that. Now next bit is 1. Next bit is 1 means there is no inversion. No inversion means it. Next bit is 1. Next bit is 1. Here no inversion. Okay. Next bit is 0. There is inversion. It is going from 0 again 1 to 0. Inversion is there. 1 to 0. 1 is there. No inversion. It continues in the same voltage and goes to. And every bit of the signal there should be a return to 0 because it satisfies bipolar satisfies the RZ scheme. Okay. So this is what. So now I will explain once again. This is a signal. Since the next data element is 1, there is no change. It continues at the same voltage and there is a change of signal as it satisfies RZ. But in the next coming is 0, there is a change. From 0 it goes to 1. 0, 1. This is so. And the bandwidth is compared to the previous, it is minimal, average, n, not n by 2. And each signal element, each data element carried by the two signal elements. In Manchester and differential Manchester encoding, the transition at the middle of the bit is used for synchronization. So for the synchronization, what is required? Transition between mid of the bit is needed. Okay, and the minimum bandwidth of Manchester and differential Manchester is 2 times that of NRZ. Okay, there is no DC component and no baseline wandering. None of these codes have error detection. These are the advantage as well as disadvantage. Now these are the references for the session 2. Thank you.